When using common software like Microsoft Word or PowerPoint, you've probably seen the term RGB used. You might have been wondering all the while what this really means. It's probably the most common standard way to specify color used in computer graphics software. RGB stands for red, green, and blue. With those three fundamental components, you can create virtually any color. It's what they call an additive process. You can see in the diagram that the addition of the pure form of all three components creates white in the middle. Adding varying intensities of red, green, and blue light together creates all of the different colors your eye sees. RGB is the color model that is used internally by displays on computers and TVs. Anything you see on display screens, no matter what color model is used in the graphics software, has to be converted to RGB to be understood and rendered by a display. RGB is the only language that a display screen speaks. Any conversion from another color model is done automatically by the display without you having to worry about it. Imagine right now that you can actually see the tiny dots on your computer screen that create the image that you see, like the magnifying glass image on the right. Those tiny dots are kind of like flashlights. Each is shining red, green, or blue. They're grouped into sets of three. Each of those sets of three is called a pixel. Each pixel contains one red, one green, and one blue dot. These pixels can appear as any color, for instance, the orange color shown here, by changing the brightness of each of the individual red, green, and blue dots. What your eye sees is not the tiny red, green, and blue dots, but the color of the pixel, which is the particular combination of those three colors. The color specification method for RGB uses three numbers to define any color. It's important to understand here that RGB is a method of creating colors by mixing varying amounts of the three base components of red, green, and blue. It's not just a numerical system for defining colors. That's a number between 0 and 255 for each of the three RGB components. Those numbers define the intensity of each of the red, green, and blue components. The reason why it's a number between 0 and 255 is rather technical. You don't need to know that. Anyway, for example, the color of the swatch is defined as 242 red, 163 green, and 32 blue. Those RGB values make the color orange that you see here. You see an example of this same RGB color defined in this Photoshop color panel. The three color values for the orange color we've been describing are highlighted. Here's a thinking on your feet question for you. Pause the video so you can think of what these numbers might be. It's not as hard as you think. When you have an idea for the answers, check them by unpausing the video. Congratulate yourself if you got any of them correct. In terms of gray, all numbers at the same value is a shade of gray. Gray is the absence of color. No one of those three RGB components stands out. All the numbers are the same. You learned earlier what saturation is. This would be zero saturation. If all three numbers are the same but higher, that is a lighter shade of gray. Lower numbers are a darker shade of gray. 000 is pure black, since that means zero intensity for each component. In other words, no hint of color whatsoever. That's what black is, the absence of color. 255, 255, 255 is pure white, since that means maximum intensity for each component. And since the numbers are the same, it's the lightest shade of gray, which is pure white. Here is a skills application challenge. Open the graphics program you most commonly use and find where in that program you set color using the RGB color model. Play around with it for a while until you're comfortable using it, and then go to the next video.